Hello again. አሁን ደግሞ እዚህ ቪዲዮ ላይ ምን እንደምናደርገው we're going to look at some MIPS code and just kind of go through it line by line ምን እያደረገ ነው የሚለውን understand ለማድረግ just get a better sense of the syntax and rules in MIPS. This is MIPS code ከቴክስትቡክ ላይ ተወሰደ. Alright, so እንጀምር. At first cluttering, we see መጀመሪያ የምናየው ኢምፖርታንት ነገር እዚህ ጋር ዶት ቴክስት የሚልና ዳውን ሂር ዶት ዳታ የሚል አለ. ኤኒታይም ዶት ብሎ የሆነ ነገር ሲጻፍ that means it's a directive. directive ማለት ምንድን ነው? It's just instructions assembly ፕሮሰሱን የሚያሻሽሉ they make it faster, more efficient and readability ላይም ይጠቅማሉ. readability ማለት as a human ይህንን MIPS code ሳነበው I can arrive at what it's doing easier. Readability is an important concept any code writing development ላይ in general. የሆነ ነገር የሚሰራ ኮድ ብቻ መጻፍ ሳይሆን እቅዳችን is to also be able to communicate with it, right? To share it. ሌሎች ሰዎች ሲያነቡትም easily grasp ማድረግ ይችላሉ የሚለው concept ማለት ነው. So directives, they are instructions, assembly procesሱን swifter ያደርጉታል. They also improve programmability. እዚህ ጋር ሁለት ዳይሬክቲቭ እናያለን. ዶት ቴክስት እና ዶት ዴታ. ዶት ቴክስት determines what goes into the program text ወይም the text segment of memory. So ከዶት ቴክስት ስር ያሉት እንዳለ እነዚህ የፕሮግራም ኮድ ናቸው ማለት ነው. That's what it specifies. So it's specifying ከዚህ ቀጥሎ ያለው የፕሮግራም ቴክስት ነው. dot data specifies what goes into the data or static segment. ቅድም ስለ memory ስናወራ ስለ static memory አውርተን ነበረ. So dot data ብዬ የማስገባቸው ነገሮች that's where I specify the data that my assembly code is using, and that's stored in the static section of memory. Okay, and this is the dot text demo is stored in the program text or program code section of memory ከዚህ ስር ነበረ እሱ ካስታወሳችሁ. So already now I have two sections of my MIPS code. የኮዴ ራሱ ኢንስትራክሽኖችን ኮንቴን የሚያደርገው and then የዴታ ሴክሽን የዴታዬን static ዳታዎችን ኮንቴን የሚያደርገው. So let's go ahead and see static data ውስጥ ምንድን ነው ያለው. So I have two things. እዚህ ጋር prompt relay dot አድርጊያለሁ, output ብዬ dot አድርጊያለሁ. So another important concept syntax ውስጥ is directive ብለን ነበር አይደል? And then now we have labels. So anything ጽፌ ሁለት ዶት እንደዚህ ማስከትለው ነገር it's known as a label. A label is essentially like a marker in the code ብላችሁ ውሰዱት. It's just a እንትን ኮዱ ላይ ማርክ ማረግበት ወይም ያቺን area of code specify ማረግበት mechanism ነው, right? So እዚህ ጋር ለምሳሌ የተለያዩ ማርከሮች አሉ. እዚህ ጋር ሜን ማርከር አለ, ፕሮምፕት አውትፑት ማርከሮች ናቸው, ሌላ ማርከር የለም. So essentially main የምትለዋ ሌብል the main method or the main the entry point in the instruction label ማድረግበት መንገድ ነው. It's not necessary because MIPS ከመጀመሪያው መስመር ጀምሮ ነው execute ማድረግ የሚጀምረው. So anyway ከዚች መስመር ጀምሮ execute ማድረግ ይጀምር ነበር, ግን for readability again and neatness እንትን ብያለሁ. But this label ለምሳሌ main refer ሳደርግ I'm referring to this point in the program. እዚህ ጋር ነው refer ማድረገው. In that same way prompt ስል እዚህ ጋር የሚደረገው ነገር ላይ ነው refer ማድረገው. output ስል እዚህ ጋር የሚደረገው ነገር ነው refer ማድረገው. So these two are labels. So what's prompt labeling? Another directive አለው እዚህ ጋር አይደል? ዶት ብዬ የሚጻፍ ነገር. So the directive እናስተካክል. Another directive. Let's see. So this specifies a string. Give me a string of give me an ASCII string, a string full of ASCII characters terminated by a null value. Z የምትሏቺ learner terminator specify metadargnat. So remember how we talked about a string in C, and in MIPS we have, like, we can refer to it both ways, but generally it's an array of characters terminated by the null byte. null terminated ስናስቀምጥ ዜሮ መጨረሻ ላይ ስናስቀምጥ again there is a difference between the character 0 as in 0 1 2 3 4 ምንላቸው ቁጥሯን እንድና የምታደርገው 0 and 0 integer value map የሚያደርግበት character, which is the null character, the null byte. So I have a series of, so ASCII የምትለዋ directive is give me a string terminated by a null byte የሚለው ነው. And what string is that? Please enter an integer የሚል ነው. So እዚህ ጋር የማናየው 0 አለ, or the null character byte. Same thing እዚህ ጋር. So prompt የምትለዋን please enter an integer ናት. output የሚለው label ደግሞ I use this directive to allocate this string in the static region of memory. ከዛ እዚች ጋር እንደምታዩት backspace እናለች. This is the character that specifies a new line, right? And then again እዚህ መጨረሻ ላይ የማናያት null terminating byte አለች, አስይዚ ስለሆነ ማለት ነው. So that's our data. So if we go back to the text and let's start. So እዚህ ጋር ኮሜንት አለኝ, ሃሽታግ አድርጌ የምጽፋቸው እንዳለ ኮሜንት ናቸው. It applies to the entire line. Prompt for the integer to enter. Okay, so now I have what I call operators. እነዚህ li, la, syscall የሚሉት እንዳለ operators ናቸው that are doing very particular things. Okay, so li is an operator that says load, L for load, I for immediate value. Immediate value ማለት ምን ማለት ነው? In MIPS, when I refer to the actual value itself within that instruction, right? So line in MIPS is the line, a combination of an operator and any data or register, whatever I pass through it. That's called an instruction, right? So instruction ውስጥ ከሆነ ኮንስታንቱን ሪፈር ማደርገው, like እዚህ ጋር አሁን specific value አለችኝ 4ን የሆነ ነገር አርጓት እያልኩ ነው within, like, to the operator. So I'm using an immediate value, ራሱን ኮንስታንቱን ራሱን ሊተራሉን እዛው ጋር ቫልዩን ሰጥቼ ሪፈር ማድረግ ከሆነ then I'm using an immediate value. So li load immediate value ይላል. So what this is saying is load the immediate value 4 at the register v0. So we talked about registers earlier. There are spaces, a type of memory that CPU uses directly access እያደረገ immediately የሚጠቀምበት memory ነው. So $v0 register ደግሞ ምንድነው ተባብለን ነበረ? v0 ሁለት እንትኖች አሉት። አንደኛው you store instructions for a system call operation essentially. And then along with v1 it's used to store return values. Right? Those are the two uses of v0. So now I'm saying load the immediate value 4 into v0. Okay, that's one thing I did. Load immediate value 4 into register v0. LA አለኝ። LA ምንድን ነው? Load address value. So each memory position, anything we put in memory, anywhere ስናስቀምጠው አድሬስ አለው ያ right? Like ለምሳሌ አንድ ሼልፍ ወስጄ ሼልፍ ባስቀምጥ የሼልፉ ቁጥር እንዳለ ማለት ነው. Just as we have, mailbox ነበሮች አሉን ምናምን, memory itself አድሬስ አለው. So each memory position has an address, right? And so what this is doing is it's saying load the address of prompt ምንድን ነው? This here I'm not using an immediate value anymore. I'm using a label to refer to something. And what am I using a label to refer to? This string, right? So prompt is a label for this string, the string I allocated using this directive. And when I say load the address of prompt, of whatever is labeled referred to by prompt, at A0 I'm saying load the address of this string into A0, register A0, right? So load address of string under prompt into register A0. Now ቀጥሎ ያለው syscall ነው. This operator syscall ስል it executes a system call, and what system call it executes is driven by whatever system call is stored into v0 እንደተባባል ነው ማለት ነው አይደል? And what's stored in v0 is the system call represented by the integer 4, and that is essentially print the string starting at address specified by A0. No. So we talked about how different register values conventionally የምንጠቀምባቸው, right? And we talked about how ከA0 እስከ A3 ያሉት arguments to routines ናቸው አይደለ? To instructions and what we pass in as arguments. So essentially A0 ላይ ምን አደረኩኝ? I gave the address of the string, and then in the instruction, the system call 4, what it does is it prints a string starting at the address that was specified here. So I'm giving it the address. String address in the we talk about the address of the first character, beginning address ነው የምንሰጠው. So እዚህ ጋር የሚጀምረውን p ያለችበት. So if this is my static section of memory እና እንደዚህ ነበር እንበል, እንደዚህ enter space ነው እዚህ ጋር ያለ ይቀጥላል, terminated by a null byte. እቺ memory 0x1 ከሆነች at A0 ያስቀመጥኩት ይሄንን memory location ነው 0x1, right? So registerውን ብንስል ለምሳሌ, that might be a good idea actually. So let's say this is my register, and I have v0, v1, a0, a1, and then whatever. At v0 4 ነው ያለኝ, right? እዚህ ጋር in binary ነው ያስቀመጥኩት እንበል, the value 4 ነው ያስቀመጥኩት. At a0 ምንድን ነው ያስቀመጥኩት? 0x1, which is the address of the beginning of this string. So now when I say system call, እዚህ ጋር ያለውን procedure ነው የሚጠራው, which is 4, and 4 is saying ከአድሬሱ beginning ጀምረ print አድርግ. So what did I do እስከዚህ ድረስ ባለው? I printed out the prompt. Prompt ምንድን ነው? Please enter an integer. So at this point the program prints out to the console, please enter an integer. That's what it says? Yeah, with a colon. So hidden print out አደረኩ. Next. So the next block is read the integer and save it in the register S0. ትዝ እንደሚላችሁ ከሆነ ከS0 እስከ S8 ያሉት ደግሞ they were dedicated for storing or saving values, right? So a ላይ ምንድነው again? Load immediate value. What immediate value? 5 into v0. Again v0 እዚህ ጋር በምንድነው መጠቀም የነበረው? It's either and የጠራሁት ኢንስትራክሽን ቫልዩ ሪተርን ሲያደርግ የሚያስቀምጥበት ወይም ደግሞ እኔ for system call ማስቀምጥበት. So 5 የሚለውን system call አስገባውና system call ጠራ. 5 ምንድናት? What's the integer 5 representing? So the integer 5 represents system call that waits for the user to type an integer. ከዛ በኋላ integer type ሲያደርግ ዩዘሩ ያንን integer ወስዶ v0 ውስጥ ይከተዋል. Because v0 also acts as a return value ማስቀመጫ. So ልክ እዚህ ጋር system call ሳደርግ ይጠብቃል አይደል? እዚህ ጋር ለምሳሌ it will just wait. ከዛ እኔ like let's say 7 አስገባው as a user አይደለ? 7 ሳስገባ 7ን ይወስዳትና አሁን I'm going to remove እዚህ ጋር 5 አድርጌ ነበር አይደለ? For the system call የሚጠብቀውን 5 አድርጌ ከዛ ዩዘሩ 7 ሳስገባ ደግሞ ሬጅስተሩ ድጋሚ ይጠፋና 7 ይገባል. So now v0 ውስጥ 7 ነው ያለው. So then ምን አደርጋለሁ እዚህ ጋር? I use the operator move. Move is an operator where you can literally move a value from one register to another. That's what it does. So I moved ከv0 አሁን የተመለሰኝ return value 7 አይደለ? To the register for saved values $S0. So እዚህ ጋር S0 ብዬ ብጀምር እዚህ ጋር 7 አስገባለሁ ማለት ነው። ይሄ የለ Okay, so now that's what this block is, right? So far I've printed out a prompt for the user. I've waited for the user to input an integer. I've taken the integer that the user inputted and put it in a register, saved values reserve ያደረኩትን register. Now output the text. user የሰጠኝን መልሼ output ማድረግ ማለት ነው። so ምን ላድርግ? load immediate value 4 አያችሁ 4 ምንድን ነበር 4 የምታደርገው? string ታወጣለች ለዩዘር። so I load 4 ከዛ ደግሞ 4 ምን ትፈልጋለች? she wants an argument, a beginning address አይደለ? for the string that የምታወጣው. so I load address into A0, the same thing I did before, but now instead of prompt, output label ምንድነው specify የሚያደርገው? the string መጀመሪያ new line ያደርጋል። otherwise the same line user የጻፈበት ላይ ነው እዚህ ጋር አሁን እንትን ብዬ አሁን ቅድም ቀልቦት ከር እዚህ ጋር ነው new line is a particular character. normally python አሁን በጣም ያበላሸናል print ራሱ new line እያስገባ print ስለሚያደርግ, right? in C ለምሳሌ ግን if you want a new line to appear, you have to use the character / and new line particularly specify ማድረግ አለባችሁ. so now I skip a line, so ምን ይሆናል? yeah, output in A0 አደርገዋለሁ, right? the address of output I load it into the argument register A0, and then I do system call, same thing as before. so now it does እቺ ተርሚናላችን ናት አይደል? እንደውም 7ን እዚህ ጋር ለሚጻፈው ልክ ኮሎኑ በኋላ ነበር 7 ጽፋለሁ, and then ይወስዳል, and then new line print ያደርግና እዚህ ጋር you entered አይደለም የሚለው you typed the number print አደረኩ። አሁን ቁጥሩ ነው የሚቀረኝ አይደለ? ምን እንትን እንዳደረኩ. so this block is done. now አሁን ይሄ output the actual number. so again into V0 system code load አደርጋለሁ. this time load ማድረገው system call በinteger 1 represent የሚደረገው system call ነው. what does that do? it prints out the value integer value at እንትን A0 ላይ ያለው register ላይ ያለውን. so again it's an instruction. it takes it out, it takes its arguments from the register A0 and it expects an integer at A0 that it will print out to the console or output. okay, so again move ድጋሚ እጠቀማታለሁ። የት ነበር ያደረኩት ቅድም? 7ን ቫልዩን S0 ላይ ናት አይደለችው? አሁን S0ን እዚህ ጋር መውሰድ ፈልጋለሁ። so አጠፋና 7 እዚህ ጋር ሙቭድ ይሆናል ማለት ነው። so A0 ላይ 7 አለኝ። ሲስተም ኮሌን አዘጋጅቻለሁ። now I just call the system call and it prints out my number. እዚህ ጋር 7 ይወጣል ማለት ነው። so that's what that was. okay, so let's do another example. so ይሄ ፕሮግራም ደግሞ ምንድነው የሚያደርገው? it reads a string from a user and then print that string back to the user. same thing except ቅድም በኢንቲጀር ነበር ስንጠቀም የነበረው፣ አሁን string አንብበን መልሰን string እናወጣለን። so again as you can see we have text እና data segment, ምንድነው data section of our program. again ይችኛዋ specifies what goes into the program text section of memory, and this specifies what goes into the the static section of memory አይደለ? prompt እና output are similar as before, it's the same thing. አዲስ ያየነው እዚህ ጋር input እና input size. so we see 2 new directives, dot word እና dot space. what does dot space do? dot space takes whatever n number you give it there and allocates that much space in memory, right? so before እንደዚህ like prompt እና output ስናደርግ ASCII የምትለው directive string-ን ራሱ ነው space ፈጥራ እንትን ውስጥ የከተተችው. so if this is the static section of memory, for example, this directive actually takes the string and puts it in there. right? please enter እዚህ ጋር space አለ። space-ዋን እየረሳኋት ተቸግሬያለሁ. but yeah, that's what it does. but each space, the dot space directive, what she does is she just reserves space in the static section of memory of the amount specified here. ስለዚህ እዚህ ጋር 81 ስለሆነ 81 bytes of memory reserve ታደርጋለች ማለት ነው, right? And that reserved space is marked by input የሚለው እንደ label act ያደርግልናል. That's how we're going to refer to whatever space is allocated here. Dot word directive ደግሞ it allocates one word of space. One word ምንድነው ተባብለን ነበረ? One word is 4 bytes. So it allocates one words of space, and then you can specify a value, an integer value that you want to initialize that space to. So in this scenario 4 bytes ያረግና 4 bytes space ውስጥ 80 የሚለውን integer value ያስገባል. Okay? All right. So we've reserved. So ምን in the data section, we've created our strings. Our prompt string አለ, please enter an integer የሚለው, and then our output string አለ, you type the string የሚለው, and then input የሚለው label ላይ ምን we have reserved 81 bytes of space in static memory. And what else did we do? We reserved 4 bytes of space in static memory and initialized it to the value 80. So 80 የምትል integer value አስቀምጠናል in static memory, right? We talked about how an integer was 4 bytes. And that's why አንድ word ተጠቅመን እንትን ያልነው. So that's our data. Let's go back to the program text. So again, we have our main. First section, prompt for the string to enter. This is exactly the same thing as we did before. አይደለ? You see? Yeah. V0 ውስጥ 4 አስቀምጠን 4 is the system call instruction that prints starting at the address. So this is the exact same thing as before. Ziga, it's slightly new. What is new? We're first loading the system call 8. We're loading the system call 8. 8 the integer 8 represents የሚያደርገው system call ምንድነው? To read the string, ከዛ read የምናደርገውን string, we will store it at memory starting at the address specified by ሁለት argument ነው የሚወስደው 8 read string, 2 arguments. Argument 1, beginning of memory to store the string in, and then argument 2 ደግሞ the size, max size of string read. This is because ለምሳሌ እንደዚህ ሪዘርቭ አድርጌያለሁ የሆነ ቦታ እንበል, right? አንብብ አልኩ, ከዚህ ጋር ጀምረ የምታነበውን ሴቭ አድርጋልኩ. ዝም ብለህ ብታነብና ብትከት we will run out of memory, right? So I wanted to read only up until the amount of memory I have reserved, amount of memory I am allowed to access. So I can say read and to store the read value at the memory location that begins here until X amount of bytes have been read, right? Max size refer ማድረግ እችላለሁ ማለት ነው. Okay, so that's the two arguments it takes. So ምን አደርጋለሁ እዚህ ጋር መጀመሪያ I load into V0 the instruction itself, which is the system call 8, and then I load the same way as up here. I load address of input into A0. So እዚህ ጋር ምንድን ነበር ሳደርግ የነበረው? I took the address, the beginning of the string, and stored it into A0 አይደለ? ከዛ ጀምሮ አንብቦ እስከ null terminating character ድረስ ወደ screen print ያደርጋል. This time I give input ስሰጥ the beginning of this allocated memory ነው የሚወስደው, right? So it takes the address here, the address of this allocated space, the beginning, and then stores that into A0. So argument 1 ጨረስኩ ማለት ነው, የቱ ጋር ላስቀምጠው የሚለውን. And then LW አዲስ ያላየናት operator ናት. LW ምንድናት? Load word, right? It just means load 4 bytes of this value, this 4 byte value. So load which word? Input size. Load word specified by this label, right? this label ደግሞ ሪፈር የሚያደርገው ምንድን ነው? the word 80 ባይት ምንድን ነው? አንድ word space ላይ 80 integer አስቀምጬ ነበረ, right? So the value in 18 ይወስድና into A1 ያስቀምጠዋል. So this is argument 2. So 80 means 80 is the max size የምቀበለው ማለት ነው. And then I do the system call. Why is it that I allocated 81 bytes of space, but then I'm only reading in 80? Pause for the user to think about it. What is the point, Ziga? What did we talk about? A string always has an additional byte at the end as the null terminating character. And it's a face as the user saskaba. Whatever I put in as my string, I will need an additional byte to null terminate that. So ምንድነው እዚህ ጋር input size, I will take in 80 characters max from the user, but allocate 81 bytes of space because I will add the null terminating character into storage so that it's ምንድነው my standard string ማለት ነው. Okay, so when I do the system call now, what it does is just accepts 80 characters from the user. Look, someone character sigaba. Now I have these 3 sets of instruction. I will output the text that I just read. So just again, the same instruction here, output string emibalo, right? And then LA, load the address at output. Output is the same thing as before. You type the string into A0 system call so that I actually print out this string. And then to print out the user string, it's exactly the same thing, except bazifanta input and something to note here right now is that this section of this memory, the memory allocated here, was changed during the execution of this program. Because at this point in the code, ይሄ data empty ነበረ in static memory አይደለ? ዝም ብሎ allocate ነበር የተደረገው. But after ልክ ይሄ execute እዚህ ጋር ነው ማለቴ. By the end of this, like after I put in, that memory has been changed. The value that the user put in has been put in that memory, right? So if I'd ይሄን እዚህ ጋር ያደረኩትን to hey, this is a mistake. I put the number. Put the text. እዚህ ጋር ያደረኩትን ይሄንን እዚህ ጋር ያለውን block ወስጄ እዚህ ጋር execute ባደረገው ኖሮ before this block it would be empty አይደለ? print የሚደረገው string. But because it is here, after I changed it, after I put something there, now user is afon መልሶ, so it goes to the input, the address of input is like the beginning of this allocated space. That space has now been filled in with the user's string, and when I print out, then I print out whatever the user wrote in, whatever 80 characters the user wrote in. Then after that is just exiting the program. 10 ማለት halt የምትለዋ system ወይም stop የሚለዋ system call ነው. I put that into V0, and when I do system call, it exists. So yeah, this was just a walkthrough of MIPS program, like 2 example MIPS programs to get you more familiar or better explain the language syntax and what it really does. So a good continuing point kazi mindino is to compare it with C. Taking a look at a C program and seeing how can I write an equivalent program using MIPS. When MIPS in code, how can I write an equivalent program using C? Or looking at a MIPS code and thinking about ways to change it. Lemsale, if I wanted to read into different sections of memory, if I wanted to print like print twice, for example. Just multiple ways of how እዚህ ጋር ባሉት ፒሶች እንትን ማለት, and then you can go further into saying what are other operations that I can do. ሌሎች ኦፕሬተሮች ምን አሉ? መደመር መቀነስስ፣ simple computationስ እንዴት ማድረግ ይቻላል? But the main thing to understand is really like, how am I interacting with memory? How am I playing with different values and the different registers to do what I need to do? እዚህ ጋር አሁን ብዙ ኦፕሬሽኖች አሉ። ለምሳሌ ሬጅስተር ውስጥ ኢንስትራክሽን አድርጌ ኢንስትራክሽኑን ኤክሲኪዩት ማድረግ ኢን ተርምስ ኦፍ ቪ0 አርጊመንት ኤ0 ኤ1 ሬጅስተሮች ውስጥ ቫሊዩ ከቶ and ምንድነው ኢንስትራክሽን ኤክሲኪዩት ሳደርግ ከነዛ ሬጅስተሮች እንደ አርጊመንት ቫሊዎችን ፓሲን ማድረግ ሪተርን ቫሊዩን አንድ እንትን ቪ0 ውስጥ ሲመለስ ቪ1 ውስጥ ቪ2 ውስጥ ሲመለስ እንዴት ነው so just it's not easy to think in these terms, but thinking in those terms is the important part, because that's what teaches you. Low level programming language teaches you how at the low level code እና ኮምፒውተሩ እንዴት ኢንተራክት ያደርጋሉ የሚለውን